Hello, welcome to the first video for IME 443, Facilities Planning and Design, offered in the Industrial and Manufacturing Engineering Department at Cal Poly San Luis Obispo. My name is Liz Schlemer, and I am a professor in Industrial and Manufacturing Engineering. I've created a set of videos, and this is the first in the series to explain the context and the content in engineering practices. To succeed in engineering and to engineer things that are helpful for people, you need to be both an excellent engineer and also understand the context in which you are creating engineering solutions. Now, this is not a small task because as an excellent engineer, it requires that you know math and science and quantitative methods and systematic approaches. But in the context area, you need to know the people that you're designing for, the environment, the political atmospheres, and so this is a very complex system. In the area of context, one of the main things that we often traditionally look at is customer desires and needs, but we also must consider ethical considerations, cultural appropriateness, political and environmental concerns, human well-being, and this is all very iterative. It's not like you just design it, you understand the context one time. You have to continuously be checking back with the customers and with those who are going to be using your products. Now, in the area of excellent engineering, this means that we need to use sound design processes, quantitative methods, and tests so that once we do a design, we're sure that the design is going to be functioning as planned. We also must always consider safety concerns. So this might be contingency analysis, or it might be making sure that safety is built into the design. Usability, because people are going to be interfacing with the products. This also requires that how do we do prototyping? And again, this is also an iterative process. So we don't just design one time, we design multiple times as we develop products and services for people to use. Now, in the area of facilities planning and design, this is not a general engineering area. It is actually a very common engineering, though, area in industrial engineering. So in the area of good engineering practices, we want to make sure we're using systematic methodologies. There's many of them. It sometimes doesn't matter which one you use, but as long as we're using a systematic approach to make sure we're getting the best designs possible. Also, quantitative methods. So being able to apply the things you've learned in your engineering education to engineering problem using quantitative methods is really what puts us apart as engineers. We also must know how to simulate and test. In the area of the context, we must understand the company culture, the ethical considerations, and also particularly the psychological aspects of space design. Because we're going to be designing spaces, we need to understand how people interface with them. Also, environmental concerns. So if there are dangerous substances or dangerous processes, that we need to make sure we're designing for that. Now, in this class, I'm going to be breaking the processes and the videos up into sort of two areas. One, the quantitative methods part, and the other is the project application part. Now, there's going to be videos that are going to be specifically looking at quantitative techniques that you will need for your exam. And there are also going to be videos that are going to look at project aspects that you'll need if you're doing a project. There also will be videos that look at both. So it might have some quantitative methods within a video that is also project related. Now again, this is a little bit parallel to the idea that you need to have good solid engineering practices within the context of things you're working on. So you need to have quantitative methods within a project that you're working on. Facilities design and planning is broken up into several different sub-areas. Now, the first is design of the facility itself, and the second is where should that facility be located, or facilities location analysis. Within facilities design, there's also three main areas, which are facilities systems design, which are things like what's the air conditioning system or the lighting system or an emergency response system. So things within the building that are built into the building are often considered the facility systems. Now, this area often crosses over into architecture or into mechanical engineering and HVAC kind of design. So it's not always something that's considered industrial engineering, but definitely because we're designing buildings, we have to consider these processes. The next area within facilities design is layout design, and that's actually where we're going to be spending most of the time this quarter, looking at how to do these design aspects. And the third area is material handling, which is also considered a very integral part of facilities design, because many facilities have quite a bit of material handling, but also it is the connective flow through the facility is often handled in material handling equipment. So understanding how to design that in a way that supports the system is very important. Now you see here that I have next to these areas, I have both project or the globe, which is the idea that that's going to be what you're going to need for your project, and then also the calculator, which is going to indicate those are the things that are being covered on the test. So you can see that if you're only interested in taking the test, there's actually quite a bit of quantitative issues that you're going to be covered. But if you're interested in doing the project, we won't be doing a project associated with facility systems ever, but we might do some things associated with location, layout design, and material handling. There is a dotted line between facility location and layout design because some of the techniques where you learn where to locate something doesn't have to just be the facility location, but it can also be an item within the design of a facility. So some of those techniques are used in both areas.